To better see what the subdivision modifier actually does, I'm going to enable wireframe in my viewport display. This will make it more obvious to see what is going on. I'll select the Susan monkey head, go to Add Modifier, and select the Subdivision Surface modifier from the list. The mesh smooths out, but because we're still in flat shading mode, you can already see the subdivisions between the original wireframe. Let's take a look at the modifier and explore some of the settings. There are two subdivision modes, Catmull-Clark and Simple. You can also set different subdivision levels for your viewport display and at render time. These can be increased or decreased independently of each other. By default, optimal display is enabled. If I untick this, all the subdivision levels will now appear in wireframe. If we switch over to simple mode, the subdivisions are now stretched across the existing faces, but the mesh retains its original shape. I'll switch back to Catmull-Clark. As with most other modifiers, you can enable or disable when the modifier can be displayed. I can view the modifier applied at render time, in the viewport, and when in edit mode. The on-cage setting is disabled right now. I'll tab into edit mode, and you'll see that the modifier is applied, but the original mesh appears as a cage around the object. Let's enable the on-cage mode. Now the edit mesh fits to the final result. The on-cage setting can resemble the optimal display. This object is still flat shaded. I'm going to switch this to smooth, and now we can see how this modifier can really help with the final result. The original mesh will now act as a cage, and as we move vertices around, the subdivided mesh will dynamically update, almost as if there was a proportional fall-off applied. There are some advanced settings which, by default, are enabled to give the most optimal results, and they can be adjusted for more specific uses should you need them. Use Limit Surface, for example, is ticked by default. The limit surface is what the Catmull-Clark algorithm would draw if subdivision was assumed to be infinite. Let's disable this setting to see what the classic Catmull-Clark subdivision does. You can see that each subdivision is approximated based on the average distance of the existing points. Each level of subdivision will repeat the process until you reach this theoretical limit. So you need to have quite a high subdivision count to approximate that smoothing. Enabling Use Limit Surface, however, the generated vertices will be drawn towards this theoretical limit, giving you a more accurate result with less subdivision. You can also increase or decrease the quality when using the Use Limit Surface method. This will further refine the approximation, and on a subdivided cube, for example, it's most noticeable around areas where the vertex is furthest from the limit surface, such as the cube's corners. Here I have a simple mesh. I've already unwrapped and added a material to this mesh. I'll enter Material Preview mode, and I'll add the Subdivision Surface modifier. Under the Advanced settings, we can use the UV Smooth to address where the UV map is stretched. It's set to keep boundaries by default, but I have set it to none, so that you can see how badly the unaffected mapping is at first. I've marked out what areas of this mesh are defined as boundaries, junctions, corners, and concave areas. As we select the various settings, you can see how each of these areas are corrected, eliminating the stretching of the UV map. The boundary smooth option is set to all by default, as this will smooth out all the mesh's topology. A boundary is an open edge. A corner is only where two edges meet. That's why when we set boundary smooth to keep corners, only these areas are kept sharp. But these areas are not, because we have extra edges meeting the vertex here. You might have marked some creases on your mesh. These are areas where you can apply heavier sharpness to where faces meet. The subdivision modifier can take these areas into account. To illustrate what a custom normal is, I'm going to add this normal edit modifier and move it up in the stack, and I'm going to set the target to this empty here. I'll set this modifier to directional, and I'll enable face orientation in our viewport overlays so that when we move the target around, we can see which direction the normals are facing. But if we enable custom normals, this will better correct for any normal customization.